Hello students, I am Dhivya, working as Assistant Professor, Department of Mathematics, Amet University, Chennai. Now today we are going to see about what is that indeterminate form in differential calculus. So now what is that definition of indeterminate form? So what is that definition of indeterminate form? So indeterminate form is nothing but we have that functions a numerator and a denominator. So that a function's a numerator denoted as f of x and a denominator denoted as a g of x. So now in f of x and g of x, substitute that a limit value in separately numerator and a denominator. So after we have to substitute that a limit of x value limit in numerator and a denominator, we have some answers in numerator answers and a denominator answers. So it depends upon the answers. In indeterminate form, we have a 7 type of indeterminate form. So in this 7 type of indeterminate form means how we have to solve it. So each and every step we have to discuss about in this sections. Here there are 7 type of indeterminate form. One is a 0 by 0, another is a infinity by infinity, another one is a product of two functions, one is a 0 and another one is a infinity. And next one is infinity minus infinity form, next one is 0 power 0, infinity power 0 and 1 power infinity. So these are 7 type of indeterminate form. In this indeterminate form we have to solve it means first we have to learn about what is that L-Hospital rule. So L-Hospital rule is nothing but after we have to identify indeterminate form of 7 type. So after we have to identify the indeterminate form means what we have to do it in L-Hospital rule means suppose for example this limit value x substitute a in f of x is nothing but a 0 and g of x you have to substitute a limit value x is nothing but a 0. So both are is a numerator is a 0, denominator it is a 0, or otherwise the same thing is we have to substitute a limit value x, we have to getting the answer is f of x is a infinity, denominator g of x, substitute that a limit value x, it is also infinity means it is that infinity by infinity. So only we are using that L-Hospital rule only that using for indeterminate form 0 by 0 or infinity by infinity form only we are using that. So L-Hospital rule is nothing but after identify this is that which type of indeterminate form 0 by 0 or infinity by infinity. So after identifications you have to one more time differentiate numerator term separately, denominator term separately you have to differentiate. After differentiation over, again substitute that a limit value in numerator separately and a denominator term separately. So again we have to conclude it is 0 by form or a infinity by infinity form. Again you have to identify it is a 0 by 0 or infinity by infinity means again you have to one more time differentiate numerator term separately and a denominator term separately. So in this way you have to proceed continuously. When you have to stop it in this form means finally when you have to got some finite answers means so in this procedure we have to stop it, or otherwise we have to proceed continuously and so on when you have to got that final answer. So this is called it as a L-Hospital rule. So already I told that 7 type of indeterminate form. So now we have to discuss about what is that indeterminate form of first type 0 by 0 form. So 0 by 0 is nothing but it is a general form is limit value extends to a f of x divided by g of x. Suppose I substitute that value of limit value x value a in numerator and denominator. After substitution of numerator value f of x I got answer is 0. Denominator term I have to got answer is 0 means it is nothing but 0 by 0 form. So 0 by 0 form means what we have to do already you know that we have to using that L'Hospital rule. So L'Hospital rule is nothing but for what? In this numerator function is f of x, one more time you have to differentiate. Denominator term g of x also one more time you have to differentiate. Again differentiation over. Substitute that a limit value x in numerator and the denominator. You have to conclude that it is again 0 by 0 or not, we have to check it. Suppose 0 by 0 form means again one more time you have to differentiate in numerator and the denominator also. Continuously this process we have to do it. So next we have to do it for one problem related in 0 by 0 form. Now look at that a problem. What is it? A question is evaluate limit value x tends to 0 x into e to the power x minus log of 1 plus x divided by x square. So in this problem we are done using that L'Hospital rule. So which type of form we have to discuss about that. So problem, what is it? Limit value x tends to 0 x into e power x minus log of 1 plus x divided by x square. So now we have to start with the solution. So first what we have to do, so in this problem is what is the type, first we have to identify. So first we have to substitute what is the limit value will be given that x value is nothing but a 0. So now we have to substitute x value become that a 0, we have to substitute a numerator and a denominator term. So x is 0 means 0 into e to the power x value is nothing but 0 minus of log of 1 plus 0 divided by 0 squared is nothing but for what? 0. So denominator is become that a 0 which is equal to 0 into anything is nothing but a 0. So 0 minus log of 1 plus 0. 1 plus 0 is nothing but 1. So log 1. Log 1 also is nothing but a 0 answer. So 0, denominator become that a 0. 0 minus 0 for what? It is a 0. So it is 0 divided by 0. So here in this problem is nothing but 0 by 0 form. So first we have to identify it is that a 0 by 0 form. So after 0 by 0 form we have to using that a L'Hospital rule. So L'Hospital rule means for what? So limit value x tends to 0. This numerator term separately differentiate and the denominator term separately differentiate. So what is the numerator term? X into e to the power x minus log of 1 plus x. So in this numerator term first we have to differentiate. So what is the first part? First part is nothing but x into e to the power x. So here it is the product of two functions. So product of two functions, what is the differentiation formula? So differentiation of uv is nothing but uv dash plus vu dash. So this is that formula we have to apply that. So here u is nothing but x and v is nothing but e power x. So now we have to using that uv rule. So here x into e power x, what is the differentiation answer? Is nothing but e power x into 1. So u v dash over afterwards for what? Plus v u dash. V is nothing but here e power x. So e power x into here in this value what is the differentiation means? X differentiation with respect to x, that is the answer is become 1. So into 1. So first part differentiation over. What is it? The second part? Here it is at a negative term. So minus of log of this whole functions we have to consider as the x. So already you know that log of x, what is the differentiation? 1 by x. Here x we have to consider as 1 plus x. So log x you have to differentiate 1 by 1 plus x. So numerator term all the differentiation over. Afterwards for what? Denominator you have to differentiate. So denominator is nothing but a x square. X squared differentiation is nothing but a 2x. So this is the L'Hospital rule over. After L'Hospital what we have to do? Again substitute that limit value x value 0 in numerator and denominator separately. So in this form 0 by 0 or finite value we have to got it or not, we have to check it. So up to this over, again what we have to do? Again we have to substitute that x value in 0 numerator and denominator. So 0 into e to the power 0 plus e to the power 0 minus 1 by 1 plus 0 divided by 2 into x value become that a 0 means 2 into 0 is nothing but a 0 which is equal to first term become that a 0 into anything become 0 plus e power 0 value for what? 1. 1 by 1 is nothing but, it is nothing but a 1. So minus 1 divided by 0, which is equal to 1 minus 1 is nothing but a 0. So numerator term 0, denominator term 0. So again this value I have got it a 0 by 0 form. So again 0 by 0 form means what we have to do? Again using that L-Hospital rule. So again L-Hospital rule, when you have to using that means before term only you are using that only for a L-Hospital rule. Don't go for that previous of the problem. So first limit value extends to 0. This is that one time of L-Hospital rule over. This functions again you have to differentiate numerator and denominator separately differentiation. So first term for what? Here it is also product of two functions. Again we are using that product of two functions. So second term e power x, what is the differentiation? Here third term, what is the differentiation of 1 by 1 plus x. So product of two functions means already you know that UV rule, apply that. So here x into u into v dash plus v into u dash. So first term differentiation over. So what is that second term? E power x. So e power x, again you have to differentiate, that answer is become only for e power x. So third term is 1 by 1 plus x. So it is nothing but you know that differentiation of 1 by 1 plus x. So again we have to write it 1 by 1 plus x is nothing but 1 plus x the whole inverse. You know that the differentiation formula for what? X to the power n, n into x to the power n minus 1. So here what is the value of n? Minus 1. Here x is considered as 1 plus x. So minus 1 minus 1. So minus 1 1 plus x minus 2, which is equal to minus 1. So 1 plus x whole power minus 2 we have to denote it as a denominator. So 1 plus x the whole square. So already we have that a negative sign. So now my answer is for differentiation of 1 by 1 plus x is also negative sign. So negative into negative, it is nothing but a positive. So now we have to write it for positive of 1 by 1 plus x the whole square. So in this numerator term over differentiation, again L-Hospital rule. Afterwards for what? In this denominator term, again you have to differentiate. So put it denominator 2x, again you have to differentiate, that answer is become that 2. So second type of, again you have to L-Hospital rule using that over. After for what? Again you have to substitute x value 0 in numerator and denominator separately. So x value 0, 0 into e to the power 0 plus e to the power 0, here plus e to the power 0 plus 1 by 1 plus 0 the whole squared divided by 2, which is equal to first term is a 0 into anything become that a 0. So 0 plus e power 1, e power 0 is nothing but 1. Here e power 0 is nothing but 1. Here 1 by 1 plus 0 the whole squared is nothing but 1. So 1 by 1 is nothing but 1 divided by 2. So which is equal to 1 plus 1 is nothing but 3 divided by 2. So now I have to got the answer is 3 by 2. So it is not a 0 by 0 form. So now I have to stop it up to this. So this is that a solution of original problem. So that the next type is infinity by infinity indeterminate form. So infinity by infinity, the same thing is substitute that a limit value, x value numerator and a denominator. We have a answer is numerator is infinity, denominator is infinity. So it has a infinity by infinity form. Whatever we have to do it for 0 by 0 form, that the same procedure we have to do it for infinity by infinity. Once you got that answer is infinity by infinity means again we are using that L-Hospital rule. So that the procedure, the same thing for us 0 by 0 form. So next we have to continue for that problem infinity by infinity. So infinity by infinity form, what is that problem is limit value extends to 0 log x divided by cot x. So now start with the solution. First I have to substitute limit value x in numerator and denominator separately. So here log x limit is nothing but 0 divided by cot 0. So log 0 is nothing but infinity divided by cot 0, it is also infinity. So in this problem it has a infinity by infinity form. So infinity by infinity form means for what? Again we are using that L'Hospital rule. So L'Hospital rule is nothing but limit x tends to 0. Numerator term, what is the differentiation? Log x is nothing but 1 by x divided by cot x, what is the differentiation? Minus of cosecant squared x. So here this is the L'Hospital rule. L'Hospital rule is nothing but numerator term separately differentiate, denominator term separately differentiate. After differentiation for what? Again we have to substitute that limit value x value 0 in numerator and denominator separately. So now in this problem I have to make that some simplification. It is possible means we have to using for simplifications, or otherwise we have to do it for that limit value x value 0, substitute it is that 0 by 0 or infinity by infinity. So in this problem I have some making for some simplifications. What does that means? Limit value x tends to 0, 1 by x divided by, here this is nothing but 1 by cosecant squared x. So before earlier you know that is one of the formula, 1 by cosecant x is nothing but sin x. Here your problem is 1 by cosecant squared x. So here 1 by cosecant squared x, which is nothing but sin squared x. So now I have to replace the answer of 1 by cosecant squared x is nothing but sin squared x. Here it has a negative sign. So now I have to put it in negative is nothing but negative of. So minus I have to put it. 1 by cosecant squared x is nothing but here into sin squared x divided by 1. So one more time, which is equal to limit x tends to 0. This is the sign of minus sign. So minus of sin squared x divided by x. So this is nothing but this L'Hospital rule we are using that. This is some we have to do it for a simplification, this one. So after for what? Now we have to substitute that limit value x value 0. So now sin squared x, so sin squared x value 0 is nothing but a 0 divided by x value denominator 0 means it has a 0 by 0 form. So 0 by 0 form means what we have to do? Again we have to differentiate numerator term separately and denominator term separately. So limit value x tends to 0, this negative sign, sin squared x, what is the differentiation? 2 into sin x into cos x divided by x differentiation for what? It is the answer has become that 1. So again this is a differentiation over. Again substitute that limit value x value 0 in numerator and denominator. So numerator minus 2 sin 0 into cos 0. Here denominator there is a no x term. So you have to put it is nothing but a 1, which is equal to sin 0 for what? 0. 0 into anything is nothing but 0. So 0 divided by 1, which is nothing but 0. So here I have to got answer is 0. Here it has a no 0 by 0 form or infinity by infinity form. So this is your final answer for this problem of original. So indeterminate form, next type is 0 into infinity. So 0 into infinity is nothing but product of two functions. So one function is f of x, substitute that a limit value got a 0. Second of a g of x function, substitute that a limit value is nothing but infinity, or it has f of x is a infinity, g of x is a 0. So anywhere it is a 0 into infinity form. So we have that a product of two functions in a 0 into infinity form means, so in this equations can be converted to rewritten in the form of f of x divided by 1 by g of x, or otherwise g of x divided by 1 by f of x. After this equations we have to write it, substitute that a limit value in x numerator and denominator. So after substitution of a numerator and denominator we have a answer is 0 by 0 or infinity by infinity. Already you know that 0 by 0 or infinity by infinity means we have to using that L'Hospital rule. So next problem is prove that limit value x tends to 0, x to the power n into log x, which is equal to 0, where n value is greater than 0. So first that a problem is limit x tends to 0, x to the power n log x. So in this problem we have to prove it, final answer become that 0. So now start with the solution. First x value substitute in 0. So 0 power n into log 0. So 0 power n is nothing but which is equal to 0. Log 0 is nothing but infinity. So in this problem it has a 0 into infinity form. So 0 into infinity form means already you know that these equations can be rewritten in the form of f of x divided by 1 by g of x, or otherwise g of x divided by 1 by f of x. So now I have to written as f of x, I have to take it as log x, g of x I have to take it as x power n. We are choosing that any value f of x and g of x. Now in this problem I have to choose in the value of f of x is nothing but a log x and g of x is nothing but x to the power n. So limit x tends to 0, f of x I have to choose in the value of log x divided by 1 divided by g of x is nothing but x to the power n. So after this equations can be rewritten in the form of f of x divided by 1 by g of x. After this functions again substitute that a value of limit value x value 0 in numerator and denominator. So numerator now we have to substitute, here is nothing but a log 0 divided by 1 divided by 0 power n, which is equal to log 0 is nothing but infinity divided by 1 divided by 0 is nothing but infinity. So in this problem it has a infinity by infinity form. So infinity by infinity form means for what? Already you know that numerator term separately differentiate, denominator term separately differentiate. So now we have to do for that differentiation. So limit x tends to 0, log x differentiation is nothing but 1 by x divided by, so 1 by x power n we have to using that differentiation. So 1 by x to the power n is nothing but x to the power minus n. So now we have to differentiate x to the power minus n, which is equal to minus n x power minus n minus 1. So this is the answer for x to the power minus n. So now we have to substitute minus n x power minus n minus 1. So this is your differentiation over. So afterwards now I have to do for some simplification. So limit x tends to 0, 1 by x divided by minus n. So now we have to split out x to the power minus n minus 1 is nothing but x power minus n x power minus 1. So limit x tends to 0, 1 by x divided by minus n, x to the power minus n is nothing but can take that a numerator term x power n. So it has x inverse is also is nothing but a x. So in this x and x will be cancelled. So remaining value, limit value x tends to 0, x to the power n divided by minus n. Now substitute that x value 0. So 0 power n is nothing but 0. Always n value does become that greater than value of 0. So it has a answer is become that 0. So now this is the final answer. So now we have to prove it, this problem answer is 0. So next form, indeterminate form, infinity minus infinity. So first function substitute that a limit value, it has a answer is suppose infinity, that second is sign is minus. Next g of x substitute that a limit value x value, we have to got answer is infinity means it is a infinity minus infinity form. So in this infinity minus infinity form we have to can be reduce the form of 0 by 0 form. So how we have to reduce the form of 0 by 0? It is nothing but this original equations can be rewritten in the form of g of x minus f of x divided by f of x into g of x is nothing but you have to take that LCM of two functions and simplify. So next problem, evaluate limit x tends to 0, 1 by sin x minus 1 by x. So start with the solution. First we have to substitute x value 0, first function and second function. So 1 divided by x value 0, so sin 0. So sin 0 is nothing but 0 minus 1 divided by x value become that 0. So here it has a 0. So 1 by 0 is nothing but for what? It is a infinity minus 1 by 0 it has a infinity. So in this problem it has a infinity minus infinity form. So infinity minus infinity form means for what? In this equations can be reduced the form of 0 by 0 form. So before we have to reduce the form of a 0 by 0 means first we have to take the LCM. So limit x tends to 0. So what is the LCM of x into sin x? Is nothing but x into sin x. So numerator term here x, here minus of sin x. So after taking the LCM, we have to substitute the limit value in numerator and denominator. So now substitute x value 0. So 0 minus sin 0 is nothing but 0. Denominator here 0 into sin 0, which is equal to 0 minus 0 is nothing but 0. Denominator 0 into anything is nothing but 0. So here in this problem it has a 0 by 0 form. So 0 by 0 form means already you know that we are using that L'Hospital rule. So L'Hospital rule we have to using that limit x tends to 0. So L'Hospital rule, differentiate numerator term separately, denominator term differentiate separately. So first term here x minus sin x. So numerator term first differentiate, x differentiate with respect to x, that answer is become 1 minus of sin x differentiation, it is a cos x divided by, here it has a product of two functions. So product of two functions means we are using that formula differentiation of u v, which is equal to u v dash plus v u dash. So here we have to using this formula, x into sin x differentiation is nothing but a cos x plus sin x into x differentiate with respect to x is nothing but 1. So this is that one time differentiation over. So this value again substitute that limit value numerator and denominator separately. So here 1 minus cos x, substitute that x value 0, cos 0. Cos 0 is nothing but 1 divided by, here first one is the 0. So 0 into anything become 0 plus sin 0 is nothing but 0, which is equal to 1 minus 1, it has a 0 divided by 0. So again it has a 0 by 0 form. So again it has a 0 by 0 form means what we have to do? This functions one more again differentiate numerator and denominator separately. Limit x tends to 0. What is it? A numerator 1 minus cos x, again differentiate. First 1 is nothing but a constant term. So constant differentiation is become 0 minus of cos x differentiation is minus of sin x. So minus sin x divided by, here it has a product of two functions. So product of two functions means what is the differentiation formula? U v dash plus v u dash. So in this way we have to proceed in denominator. So x into cos x differentiation is minus sin x plus u v dash over plus v u dash is nothing but cos x into x differentiate with respect to x is nothing but a 1 plus sin x differentiation is nothing but a cos. So differentiation again over, again substitute that limit value. Here it is nothing but negative into negative positive. So it has a sin 0 is nothing but 0, denominator it is 0. Here first one cos x substitute that x value 0 means it is nothing but a 1. Second cos x value, so substitute x is 0, so plus 1 which is equal to 0 divided by 0 plus 1 is nothing but 2. So here it has not a 0 by 0 form, it is a 0 by 2. So 0 by 2 is nothing but 0. So this is the answer for your given original problem. Next type is indeterminate powers. So indeterminate powers is nothing but a limit of x tends to a, f of x power of g of x. So now substitute that f of x value, after substitute limit value 0, then g of x value 0 means it is a 0 power 0 form. The next one f of x value substitute limit, it has a answer is infinity, and g of x substitute limit value become that answer is 0 means it is a type infinity power 0. Third one is substitute limit value f of x is nothing but 1 and g of x is nothing but a infinity means it has a 1 power infinity. So in this type of cases of indeterminate powers means what we have to do it in a indeterminate form. So we have to do it that a given original problem we can take it as y equal to, so y equal to f of x power of g of x. So we can take that log on both sides, so y equal to log y equal to g of x into log of f of x. So in this functions can be reduced the form of 0 into infinity form. So 0 into infinity form means already you know that. So that equations can be reduced the form of 0 by 0 or infinity by infinity. So product of two functions means that the equations or functions can be rewritten in the form of f of x divided by 1 by g of x. Next, the problem, evaluate limit x tends to pi by 2 sin x power of tan x. So here this is the indeterminate powers of functions. So now start with the solution. First substitute the limit value. So sin pi by 2 power of tan pi by 2. Replace the value of x value. So sin pi by 2 it is nothing but a 1. Tan pi by 2 it is nothing but a infinity. So here in this f of x power of g of x is nothing but 1 power infinity form. So 1 power infinity form means these equations can be reduced the form of 0 into infinity. So 0 into infinity, how we have to convert it is nothing but given original problem we can take it as y equal to. So let y equal to limit x tends to pi by 2 sin x power of tan x. After we can eliminate the power value. So how we can eliminate the power is nothing but taking log on both sides. So log y which is equal to limit x tends to pi by 2 tan x log of sin x. So here tan x is a one function, log of sin x is a another function. So here it is a one function and another functions means it is a product of two functions. So product of two functions means it has a 0 into infinity form. So now we have to check it is a 0 into infinity form or not. So now substitute x value pi by 2. So tan pi by 2 into log of sin pi by 2. So sin pi by 2 is nothing but 1. So log 1 is nothing but a 0. Tan pi by 2 is nothing but it is a infinity. So log of sin pi by 2 which is equal to tan pi by 2 is nothing but a infinity and sin pi by 2 log of sin pi by 2 it is nothing but a 0. So this function it has a 0 into infinity form. So 0 into infinity form means what we have to do? So in this equations can be reduced the form of f of x divided by 1 by g of x. So in this equations can be rewritten in the form of limit x tends to pi by 2. Here I have to take it as f of x is take it log of sin x. So log of sin x is nothing but a f of x divided by 1 by g of x is nothing but a tan x. So 1 by tan x. So this is f of x divided by 1 by g of x form. So here f of x divided by 1 by g of x form means now substitute that x value pi by 2. It has a 0 by 0 or infinity by infinity, we have to check it. So substitute that log of sin pi by 2 is nothing but 1 divided by 1 by tan x is nothing but a tan pi by 2. So tan pi by 2 is nothing but a infinity. So it has a infinity by infinity form. So infinity by infinity form means what we have to do? Numerator term separately differentiate and the denominator term separately differentiate. So before we have to differentiate, so I have to make that some simplification is nothing but limit x tends to pi by 2. So log of sin x divided by 1 by tan x. So 1 by tan x is nothing but a cot x. So in this functions again we have to differentiate using El Hospital rule. Limit x tends to pi by 2. Log of sin x is nothing but 1 by sin x into cos x divided by cot x differentiation is nothing but a minus cosecant squared x. So, minus cosecant squared x. So, here limit value extends to pi by 2 cos x divided by sin x into this negative sign. Already you know that 1 by cosecant squared x is nothing but a sin squared x. So, you can put it sin squared x. So, here one sin and sin squared cancel, remaining value limit extends to pi by 2 minus of cos x into sin x. So, now we have to substitute x value pi by 2. So, substitute that x value pi by 2 means minus of cos pi by 2 into sin pi by 2. So, cos pi by 2 is nothing but a 0 into sin pi by 2 is nothing but 1. So, 0 into 1 is nothing but a 0. So, here it has a no 0 by 0 or infinity by infinity, only for 0 answer. So, this is the final answer for your original problem. I hope you all, so all the sections of whatever we have to take in the sections we are understand. So, next we have to discuss about that the same thing is we are using that a series expansion in indeterminate form. So, it has any doubt means we have to clarify that. Thank you.